concept of not needing explosion-proof boxes is a misnomer. National Electrical Code Section 500.8 and 500.2 require all wiring for Class 1 locations to meet the requirements of Part 10 of Article 501, the hazardous classified location article. Article 501.4 permits the use of explosion-proof enclosures, or the equivalent. The phrase "or the equivalent" has been defined by various authorities having jurisdiction in different ways. In my opinion, the most common and sensible method of interpreting "or the equivalent" is to apply the guidelines provided by Underwriters Laboratories. Underwriters Laboratories F398 standard specifically states that properly installed and maintained non-explosion-proof equipment within splash fill areas adjacent to gasoline dispensers are equivalent to explosion-proof equipment. Also, the fact that diesel dispensers are considered unclassified per 500.2 (AUN) does not mean that the entire fuel island is unclassified, nor does it mean that all wiring on the island may be non-explosion-proof. All wiring within the splash fill area, per 501.4 (BON), must be an explosion-proof enclosure, or the equivalent per Underwriters Laboratories F398. Here is one more point. Specific requirements for conduits under 501.4 BON cannot be provided since the National Electrical Code does not provide for conduit requirements specific to gasoline dispensers. However, 501.4 does permit the use of non-explosion-proof enclosures or conduit systems that are designed and installed in a manner that will prevent any hazardous vapors from entering or accumulating within them. This is a tall order for a conduit system. It is highly impractical, if not impossible, to meet this requirement. As such, it is recommended that conduit systems be avoided altogether in these spill-fill areas and that approved cable systems be installed in raceways in accordance with 501.4 B. To elaborate further, let's break down the key sections of the National Electrical Code and Underwriters Laboratories standards mentioned. Firstly, National Electrical Code Article 500 addresses hazardous classified locations. This article defines different classes, divisions, and zones based on the type of hazardous material present and the likelihood of its presence in ignitable concentrations. Secondly, Section 500.8 specifically mandates that all wiring within these classified locations must comply with the requirements outlined in Part 10 of Article 501. This ensures that the electrical systems are designed and installed to minimize the risk of ignition. Thirdly, Section 500.2 provides guidance on classifying areas around dispensing devices. While it may seem that diesel dispensers are automatically considered unclassified, this is not always the case. The classification depends on the presence of other flammable liquids like gasoline or the specific design of the installation. Fourthly, Article 501 focuses on the detailed requirements for electrical equipment and wiring in Class 1 hazardous locations. These locations are characterized by the presence of flammable gases or vapors. Fifthly, Section 501.4 allows for the use of explosion-proof enclosures or equivalent methods to protect electrical equipment from causing ignition. Explosion-proof enclosures are designed to contain any internal explosion and prevent it from propagating to the surrounding atmosphere. Sixthly, the phrase "or the equivalent" introduces the possibility of using alternative methods that provide an equivalent level of safety. This is where Underwriters Laboratories F398 standard comes into play. Seventhly, Underwriters Laboratories F398 specifically addresses the requirements for electrical equipment within the splash fill area of gasoline dispensing facilities. It defines the conditions under which non-explosion-proof equipment can be considered equivalent to explosion-proof equipment, provided that it is properly installed and maintained. Eighthly, Section 501.4 mandates that all wiring within the splash fill area must be installed in explosion-proof enclosures or their equivalent, as defined by Underwriters Laboratories F398. This area is considered particularly hazardous due to the potential for flammable vapors to accumulate. Ninthly, regarding conduit systems, Section 501.4 permits the use of non-explosion-proof enclosures or conduit systems if they are designed and installed in a manner that prevents hazardous vapors from entering or accumulating within them. However, this requirement is extremely difficult to meet in practice. Tenthly, it is generally recommended to avoid using conduit systems in spill-fill areas due to the challenges of preventing vapor accumulation. Instead, approved cable systems installed in raceways are a safer and more practical alternative. The interpretation of or the equivalent by authorities having jurisdiction is crucial. Authorities having jurisdiction have the authority to interpret and enforce the National Electrical Code. Their interpretations can vary, so it is important to consult with the local authority having jurisdiction to ensure compliance. Considering the practical implications, installing and maintaining a conduit system that completely prevents vapor intrusion is exceptionally difficult. Any gaps or leaks in the conduit can allow vapors to enter and accumulate, creating a potential hazard. Therefore, the use of approved cable systems in raceways is generally preferred. These systems are designed to minimize the risk of vapor intrusion and are easier to install and maintain. Cable systems offer several advantages. Firstly, they are typically sealed to prevent vapor intrusion. Secondly, they are easier to inspect and maintain compared to conduit systems. Thirdly, they can be installed in a variety of raceways, providing flexibility in design and installation. To further clarify the requirements, consider the following scenarios. Firstly, Scenario 1, a diesel dispenser is located on a fuel island that also has gasoline dispensers. In this case, the area around the diesel dispenser within the splash fill area must comply with the requirements for Class 1, Division 2 hazardous locations. Explosion-proof enclosures or equivalent methods, as defined by Underwriters Laboratories A398, are required for all wiring and equipment in this area. Secondly, Scenario 2, a diesel dispenser is located on a fuel island that does not have any gasoline dispensers. The area around the diesel dispenser may be considered unclassified, but this depends on the specific design of the installation and the approval of the authority having jurisdiction. Even if the area is considered unclassified, it is still important to follow good electrical practices and ensure that all wiring and equipment are properly installed and maintained. Thirdly, Scenario 3, a diesel dispenser is located inside a building. In this case, the area around the diesel dispenser may be considered a Class 1, Division 1 hazardous location, depending on the ventilation and other factors. Explosion-proof enclosures and other specialized equipment are required for all wiring and equipment in this area. The following points should be considered for best practices. Firstly, always consult with the local authority having jurisdiction to determine the specific requirements for your installation. Secondly, use only approved equipment and materials that are suitable for the hazardous location. Thirdly, follow all applicable codes and standards, including the National Electrical Code and Underwriters Laboratories standards. Fourthly, ensure that all wiring and equipment are properly installed and maintained. Fifthly, conduct regular inspections to identify and correct any potential hazards. In conclusion, understanding the wiring requirements for diesel fuel dispensers in hazardous locations is crucial for ensuring safety and compliance with regulations. While diesel dispensers may sometimes be considered unclassified, this is not always the case. The classification depends on various factors, including the presence of other flammable liquids and the design of the installation. It is essential to consult with the local authority having jurisdiction and follow all applicable codes and standards to ensure a safe and compliant installation. Remember that the use of explosion-proof enclosures or equivalent methods, as defined by Underwriters Laboratories A398, is often required for wiring and equipment in splash-fill areas. Conduit systems should be avoided in these areas due to the difficulty of preventing vapor accumulation. Instead, approved cable systems installed in raceways are generally preferred. By following these guidelines, you can help to minimize the risk of ignition and ensure the safety of your fuel dispensing facility. Consider also the importance of proper grounding and bonding in hazardous locations. Grounding and bonding are essential for preventing the buildup of static electricity, which can be a source of ignition in hazardous atmospheres. All electrical equipment and metal components should be properly grounded and bonded to create a low impedance path for fault currents. This helps to minimize the risk of electric shock and prevent the accumulation of static electricity. Furthermore, consider the selection of appropriate wiring methods. The National Electrical Code specifies various wiring methods that are suitable for use in hazardous locations. These wiring methods are designed to provide a high degree of protection against mechanical damage, chemical attack, and other environmental factors. It is important to select a wiring method that is appropriate for the specific application and the type of hazardous material present. Additionally, remember the importance of proper sealing and drainage. Sealing and drainage are important for preventing the ingress of flammable liquids and vapors into electrical equipment and raceways. Seals should be installed at all points where conduits or cables enter enclosures or pass from a classified location to an unclassified location. Drainage should be provided to prevent the accumulation of liquids inside enclosures or raceways. All of these aspects are crucial for ensuring the safety and reliability of electrical systems in hazardous locations. Neglecting these details can have serious consequences, including explosions, fires, and injuries. Always prioritize safety and compliance when working with electrical systems in hazardous environments. Seek expert advice and guidance when needed to ensure that all requirements are met and that the installation is safe and reliable. Remember, the safety of personnel and property depends on it.